Greetings from Umaii Shipping School. We are conducting coaching classes for chief mates, returns and oral examination. In chief mates returns, we are conducting coaching class for phase 1 and phase 2 stability and navigation as well as for cargo work. And today it is a demo video with respect to subject concerned with chief mate stability, in particular about the phase 1, and it is conducted by Dr. B. Rajesh Reguram, who has done his BE Marine Engineering and MTech in Naval Architecture from IIT Madras and PhD in Naval Architecture from IIT Kharagpur, and he has a vast experience in the field of teaching stability, and he also worked in most mainstay and handled teaching stability and SIMT also, and as of now we are conducting coaching classes. And the basics of ship stability is all about the ship shape and the ship three-dimensional distribution of the area and volume. So basically, to understand the ship stability, the ship line plan is very, very important, and in this video we will have a basic understanding about the ship line. Basically, a ship is a three-dimensional body which is symmetry about x-axis, that is along the length of the ship, and along the breadth of the ship it is called as y-axis, and along the depth of the ship it is called as z-axis. So normally what we will do is, along the length of the ship we will divide the ship into equal number of frames. And that is, we will be dividing the length of the ship with equal number of stations which will be spaced equally. And upon each and every station we will cut the ship in the YZ plane. That is, along the breadth of the ship we will remove the forward part, and what is the shape of the ship which is available we will draw along the YZ plane. That is, this is my Y plane and this is my Z plane. And this how we are drawing, which I will explain it to very clearly in the upcoming videos. And basically, when you are cutting the ship along the length of the ship, that is along the X, this is my X plane and this is my Z plane, along the midship, you can find my shape of the ship will be looking like this. And also, if you are cutting the ship along the, that is X and Y plane, you can find the water lines, and you can find the shape of the water line will be coming like this. And all these three plane, that is, since it is a 3D object, we are dividing that 3D object into 2D, and we are combining together to form the 3D object. Now, what are the hull form nomenclatures? And you all know that it is the length overall will be the length from the foremost and aftmost part of the ship, and the length between the perpendicular is between the perpendicular, and DWL, that is the design water line, and in your terminology you will be telling us the summer load line. Now here you will be having a clear picture. Now the shear plan. The shear plan is, how we will normally do is, we will take the three dimensional of the ship and along the center line. See, this is the center line of the ship. We are cutting the ship with a plane which is along the length of the ship and along the depth of the ship. Therefore, this plane is called as X and Z plane. That is, this is the x-axis and this is the z-axis. And when we are cutting this plane and I am removing this forward part, I am removing, the shape which we are getting out is called as this outer shape. The net available shape at that point is called as the outer shape. And next we are cutting the ship by using this plane. That is, some distance apart from the center line of the ship. This is the spacing, equally spacing. And when you are cutting the ship and when you are taking this part out of the shape which we are getting is this inner shape of the vessel, and this line is called as the buttock line. Now coming to the aft-thrust plan. Now this aft-thrust plan is called, maybe also call it as the water plane area curve. Now here you can see the ship is being cut by using X and Y plane, that is, this is the X axis and this is my Y axis. You can see the planes are moving like this. When I am cutting, you can see I am just cutting this plane and cutting with this plane and move, and I am removing the outer above part of the vessel, and when I see the vessel from the top, the water plane, how the water plane area is looking is, this is how my water plane area is looking. Then once again come to the next water line, cut it off, remove the above part of the vessel and see this is my water plane, how it is looking. And below, if you are cutting it out and remove the upper part of the vessel, this is how the shape of the water line. Now coming to the body plan. As I mentioned, the entire length of the ship will be divided into equally spaced stations, and in each and every station we are cutting it with a plane in the Y and the Z axis. For example, this is my forward part of the ship, and I am cutting with this plane, and I am removing the part which is in forward of this plane, and when I am looking from this direction, the shape will be looking like this. And when I am cutting with this plane and removing, my shape will be looking like this. That is from forward. When you are looking from the forward, since there is symmetry about both the axes, we are drawing it on only one side. That is, from midship, the stations which are on the right side, I am drawing it from midship to the right side, and from the midship which are on the station to the left side, I am drawing it to the stations on the left side. This is the universal standard. Why we are drawing this half-breadth plan on the right side and the left side is, the reason is why is this. From the midship, which are all the stations towards the right side, I am drawing it on the right side of the body plan, and from the midship, which are all the stations on the left side, I am drawing onto the left side of the plan. That's why the overall body plan is going to look like this. Now, this combination of all together, that is the shear plan, the body plan, and half breadth, is totally called as the 6 lines plan, and this is for example, and the real shape it may vary. And this is a very, very important question for your phase 2 written part. Compulsory out of 1 this will come for your exam. Now I am going to talk about the symptoms for you. Let me consider a line and I am having a curve over it. To find the area under this curve, we are using Simpson's first rule. When we can use the Simpson's first rule? When we are having equally spaced ordinates and the distance between the ordinates is 5. Let y1 be the ordinates of the first one, y2 be the ordinate of the second ordinate, and y3 be the ordinate of the third ordinate. When under such a condition, the area under this curve can be written as h by 3, that is the spacing by 3, into 1y1 plus 4y2 plus 1y3. This can be also be proved mathematically, which I can prove during my regular online class. Coming to the next part, I am having a baseline and also I am having a curve. I am having the ordinates. That is 1, 2, 3, 4, 5 ordinates. Now the same as that of previous curve where there are only 3 ordinates. Now we are having 5 ordinates. Then since there are odd number of ordinates, we can use Simpson's first rule. And the spacing between each and every ordinate is h. Let y1 be the on y1, y2, y3, y4 and y5 be the ordinates. Now I am taking the same thing. It is coming into picture. This yellow mark is considered as A1 and the red is considered as A3. For this y1, y2, y3 which is being spaced equally, we know the area which is given by A1. This is my initial formula, that is h by 3 into 1y1 plus 4y2 plus 1y3. For the second area A2 which is marked in red, the 3 ordinates are y3, y4 and y5, and the area A2 will be h by 3 into 1y1 plus 4y4 plus 1y5. When you are adding these two, the total area will become A1 and plus A2. This h by 3 will be in common 1y1, 4y2, this 1y3 plus this 1y3 and 4y4 plus 1y5. Now the total area now becomes x by 3 into 1y1 plus 4y2 plus this 2 is added to become 2y3 plus 4y4 plus 1y5. In Simpson's first rule, you can find it starts with 1, 4 and it ends with 4, 1. So, since it is an introduction class, I am just finishing it over here. And for anybody who wants to join for the stability class on online, you can connect me through my YouTube channel, and this will be posted in the YouTube channel also, and the classes will be starting in the first week of every month, both online as well as direct. Thank you.